give it to you. But like I said, I don't want to give you all of it so that you need to, develop your own confidence in being able to code, because gradually we'll, deal with more complex, algorithms and so on. Okay. So, Okay, so one of the handouts that I'll also give you is, gradually we'll be dealing with, so the way we'll proceed is in the beginning, I'll have you write code from scratch, just like we talked about. You'll write it, you'll run it, you'll see, you'll feel comfortable it, but after about maybe a couple of more lectures, then you'll have enough understanding of the code so that we don't have to slow down by writing everything ourselves. Then we will move to the TensorFlow library, and I'll show you how we can, again, customize it to the best of our abilities so that we can be productive and deal with more complex problems, right? So, in order to install the TensorFlow library, some of you already have done it, so you don't have to, if everything is working for you, you don't have to do anything. But in my experience, if you are going to be using Visual Studio for Python development, okay, and you don't have to, by the way, if you use any other environment, I'm perfectly okay with it. But I prefer Visual Studio mainly from the debugging point of view, also because, I program in C++, C#, and so on, so I can easily switch with the same environment if needed. But anyway, there's a little bit of a setup involved in Visual Studio on how to set up the TensorFlow properly so that it recognizes the GPU. So hopefully tomorrow I'll put a handout over here so that you can follow step by step and have the TensorFlow. Other thing you will also need is OpenCV for being able to manipulate images and so on. So how do we install it within the Visual Studio environment? I'll give you a step-by-step instruction, so if you can do that. Anyway, so then typically, and hopefully you guys tried one of the handouts, but just very, very quickly. If you launch Visual Studio, if the environment is set up properly, right, then typically for Python, you go File, New Project. Okay, sorry, File, New Project. Okay, and then over here, under the languages over here, a little bit later, let me minimize the Visual C#, you'll see Python. Okay, if I have time, sometimes if I create a more involved machine learning code, I expose it as web services so that then I can write a C# or a JavaScript client and call it and from somewhere else. Then there's different categories over here. For example, there's a Flask web project for creating web services. I can show you later how to do that. But for right now, Python application is the main thing that you guys will be doing. So you'll select Python application. You'll browse to a folder where you wanted to store this project. So for example, if I go to C drive, I have CPEG586 _SP 2019. If I select that folder, now I'll give it a project name. For example, let's say first Python or something. Okay, So again, Python application. Project name first Python, and I browse to a location of a folder so that it will create a sub-project under there in a Python type of project. Anyway, once you do that, it will create a very simple file for you, like you'll see on the right-hand side, first python.py, and there's nothing in it, right? We always need a main program. Actually, you don't need, you can start executing, but it's a good idea to have a main. So the syntax for main is a little bit tricky in Python. So, but in Visual Studio, this is what you will do. Type in main, M-A-I-N, and then hit the tab twice. So main, tab, tab. Okay. So what it will end up doing is immediately end up writing the main for you.
Is it if underscore?
Okay, so now we have the main, and now you can start, writing the code. For example, a equal to 5, equal to 7. Just a very quick test, C equal to A plus B. And so anyway, so very simple test. So to run it, you'll go debug, start with our debugging. And it will give you the 12 answer. In case it's a long computation, it did not produce the correct result, then the debugging is exactly like if you were debugging in C++ or C# using Visual Studio. In this gray area, you can put a breakpoint by clicking on this. So this is called a breakpoint. Then what you do is you go debug and start debugging. So it will compile, it will run and stop at the breakpoint. Okay, so it turns into a yellow. And now if whatever statement has executed, you put your mouse on it, it will tell you the value is 5. Then if you hit F10 on the keyboard, like if you see debug, step over is F10, is the shortcut. So F10 will go execute the next line. Now you can put your mouse on B, F10, put your mouse on C, and so on. Okay, so, 2 more minutes, then I'll give you a break. So let me now show you the code for the MNIST digit recognition. So anyway, I created some small test program over here. So let's just focus on the important part. Okay, so if you take a look at my screen, let me show you on my computer. On the D drive, I have a data folder. Oh, sorry, I copied it from, I copied it from my other computer where so anyway, let's pretend for the time being in this particular folder, in this train folder, we have not 60,000 because 60,000 takes a long time to train. Let's pretend we have 1,000 images of digits. So in Python, if you wanted to read this data, so remember what we want to do is we want to do 1,000 and then 784. But each digit is, as I mentioned, what was the size of this digit? 28 by 28, right? So first what we'll do is using OpenCV, and I'll provide you this code, so don't worry about this part. I'll give you this code. So for right now, you can just try to understand. So OpenCV library has an IM read function, And if we give it a file name, like a JPEG or a bitmap or whatever, it will read it into a two-dimensional array. And it has two parameters over here. One parameter over here. 0 means read it as a grayscale. 1 means read it as a color image. Okay. And then do you notice over here I'm dividing by 255. So at this point in time, each one of these will be a 28 by 28, but each pixel value will be divided by 255, right? And because I only wanted 1,000 images, so I got out of the loop after 1,000. Okay, so then once I've read all the 1,000 images, at this point in time, the train folder, its shape is 1,000, comma 28, comma 28 is the shape of it, right? But what I want to do is I want to feed it to our network, as we discussed, how many inputs our neural network will have?
784.
784. So I want to change this to 784. So Python gives us a very nice capability called reshape. Okay. So you specify what should be the dimension. So train shape of 0 is 1,000. Okay, so this will be 1,000. Shape of 1 times shape of 2. So this is 28, this is 28. So that will make it 784. So basically I'm changing this to train X will become 1,000, comma 784, comma 1.
Can't we just pass in the tuple 1,000, 784?
We could. I forgot why I did one extra one over there, but it makes it easier to pick an index because each matrix needed to be 784 by 1, not just 784. Because we want to treat it as a matrix as we feed it to our neural network. Anyway, so the first code, as you can see, is simply going into a loop, reading all images from a folder, and then reshaping it to become 1,000, comma 784. And I'll provide you this code, reading the images, reshaping it. Okay, but now let's take a look at the main code over here and see if it's making sense. Okay, what is this doing over here?
Initializing random weights.
Random between a certain range and the matrix sizes that we discussed on the board. Everybody agrees? So same sizes, right? Then we go into a double loop for n in range, 0 to 100. So can you guess what is this?
100
Number of
100 epochs.
100 epochs. Okay, and okay, then we go into the second loop. I should have removed this comment, but anyway. Train X dot shape of 0. So
That's the 1,000.
that has 1,000 exactly. Because remember, train X was 1,000 after I reshaped it. So shape of 0. So basically, I'll go through 1,000 training examples. Each time I pick one example. And multiply it by what? W1. Is this a matrix multiplication? So that's why you see NP dot dot. Okay. Anyway, A1, and as I mentioned, NP.exp is capable of operating on the entire matrix to do exponent on each element. So that will give me the A1 value. Okay. Very similarly, let's go, forget about the others, S2. Does that make sense?
Yes.
W2, A1 plus B2. Okay, then A2. Makes sense? Right? Do the sigmoid on each. As we discussed, the loss will be element by element multiplication between A2 minus train Y, right? And then at the end we do the sum. So pretty straightforward. Okay. So I broke it in two parts. I didn't have to. Gradient of the sigma 2. So basically this is A2 over here, right? This is S2. So this is my second level neuron. So the gradient of this activation function is A2 times 1 minus A2. And is it a matrix multiplication or element by element? Element by element. So, right? Then delta 2 is further y minus a, and then multiplied by the gradient of the sigmoid. So, which is again element by element. So delta 2 is pretty straightforward, correct? Okay, from there we go find the delta W2. Okay. Anyway, so hopefully you'll see, as we discussed, this will be the transpose of the delta 2 times, transpose of the previous output times delta 2. And anyway, then further gradient of sigma 1 multiplied by, so somewhere you'll see element by element, and at the end, after we have created all these delts, del W1, which I'm calling grad B1, grad W2, and so on. Okay. Then what do we do at the end of the loop?
Update the parameters.
Update the W2s. And this is a simple matrix subtraction. And this is element by element multiplication. So if we do, because this is just a number, right? In the beginning, I had initialized it to 0.1. So basically, it's multiplying each element over here. Anyway, that's the basic loop. After I'm done through one epoch, so after I'm done through one epoch, okay, then, so this is after the entire single epoch is done, then I print the loss to see is it training or not. Okay, one more second and we can take a break. Is if I run it now. So like I was saying to answer the earlier question, why do we, oh, I don't have the data on this computer, so I can't run it.
What is the back propagation?
What's that?
What is the back propagation?
The back propagation is this double loop over here. So remember we did the forward pass? Then we computed the gradients, the deltas and the gradients, and then we adjusted the weights. Okay. Anyway, let me see if I can get the data, and then I'll run it and show you how the loss is going down as we are training. Okay. Let's take a 10-minute break.